Another draft physics presentation and such. So yes, this is draft science against the two-slit experiment, and again, maybe a little more organized. We'll see, graphically anyway, a little bit better. So Hoffaday has made a video claiming or trying to argue that because every now and then physicists say, "Oh, we really don't know," and there's particle duality or something else, that somehow that undoes the part where they say over and over again ad nauseum how it's been proven that light's a wave, and nail in the coffin evidence of the Young experiment. This stuff is said over and over and over again, and somehow they think it's all undone because they talk about how, well, the quantum world is so mysterious, and so therefore they've undone their aggressive assertions, basically closing conversation to even speculation regarding a particle theory of how photons work. They don't open the door, they don't explore the possibility, they don't spend any time illustrating thought processes or the logic that would be involved if it was particles, what could be a possible explanation. No time at all is spent by any physicist or any lay people on the internet talking about that. And certainly even the cranks are disappointing. I mean, the anti-conventional reasoning, because they aren't very specific about doing any of that either. They don't draw too many pictures of how their model works. And I've clearly done lots of exploring about possibilities regarding what the field of electrons, not an electrical field, but just the idea of free electrons, and the fact that photons really only interact with electrons and protons. They have to hit something. If they don't hit something, you can't know of their existence. They have no relevancy if they don't hit an electron. It's the only way you can detect the fact that they're there. The only way. There's no other way. There's no way to rub up against a photon or to sense it or to in any way detect it, except to completely interact with it as an electron does. Simple explanation for much of the phenomenon in the universe, actually. But anyway, so we'll go through some of these points that haven't been addressed, and that it's all about this perspective and how they tell the story. So how many times have they told this story wrong? and wrong in the sense they'll bring up the two-slit experiment and just completely ignore that 150 years before Young, Newton had discovered the phenomenon of small aperture diffraction in the form of Newton's rings, that it's exactly the same phenomenon, just circular instead of linearly portrayed, but exactly the same functions. And it's basically the single slit experiment, and it demonstrates the same pattern, the same phenomenon. And most physicists will admit that it's the same mechanism. Whatever's happening in one is the same thing that's happening in the other. And that the truth is that the Young experiment was completely unremarkable. So you have somewhere in the 1650, let's say, Newton discovers this thing that light does, this phenomenon of the fact that it does this diverging from its straight line path when it goes through a small aperture. And then 150 years later, 1801, Young comes along and discovers that two slits create this phenomenon. And there's never been any connection between those two events, as being, again, the 1801 event is unremarkable. It doesn't deserve to even be noted. It's a phenomenon the scientists should have already been aware of. There's just nothing. It's a lot harder to explain Newton's rings than it is to explain the Young experiment, because you don't even have the option of imagining photons going through both slits and interacting with each other in some way. you just have one slit. And especially when you start considering a single photon at a time and doing the experiment one photon at a time, you know, the single slit becomes even harder to explain in terms of the difference in the probability being variant. By any other explanation then, well, yes, the closer the light is to the surface, the more it diffracts, the more it bends, would be the logical conclusion. And quantum mechanics completely eliminates all of that as an explanation, and everything becomes dependent on just doing probability math, which may be a correct way of interpreting the phenomenon in some respects, in the sense that portions of the reaction could certainly be just probabilistic, and it really doesn't depend so much on proximity, but proximity would have a proportional impact, but not a exclusive impact. That's probably a more complex argument that I want to make, but anyway. There's just no, it's never described accurately. They always say, you know, when they have the two slits, they'll say something like, you know, if we blocked one of the slits, then the photons would just go straight and it'd all be a blob at the other side. And it's completely inaccurate. It's just, it completely ignores again what Newton discovered in 1650. I mean, a long time ago. It's really old science. It's a really old fact. And it's completely ignored in the conversation because it breaks the chain of magical description. It's the part in the story where they glue the horn onto the horse's head. So they can't tell the unicorn story if they include the part where they glue the horn on the horse's head. Because then it's the horse having a horn glued on its head story, and not the unicorn story. And so this deliberate effort to remanufacture the history and the context and the facts of what actually physically happens. They just completely ignore what is known phenomenon because it's not fun. It's not part of the fun story. The truth doesn't fit, and so they don't tell the truth. And you know, it's just a fact. It can be demonstrated. It happens over and over and over and over and over and over. All right, so I have to actually get to this in here. Yeah, I can't scroll somewhere else. So scroll down here a bit. Alright, so the Young experiment was not a significant discovery. The single slit is the game. Newton's rings. And Huygens was around in Newton's time, and I don't know if he specifically theorized using Huygens' principle to explain Newton's rings, but certainly the principle was used to describe diffraction in water, and so other things that change the path of water, or change the path of light in other circumstances. Certainly Huygens was applied. And in this slit experiment, it's applied in this manner where, as I've pointed out, in the single slit experiment, Huygens is used to create two photons. So now there's some possibility of interference, because it's essentially creating two identities, two discrete things. So one discrete thing goes in, two discrete things come out, and now they can interfere with each other in some way. And in the double slit experiment, though, Huygens is negated through mathematical chicanery and premises. So they basically just established this two slits, the same exact slit that was in the single slit. There's just another one of them. And now all of a sudden it's a single point source. It just creates one wave. So the same slit in one experiment creates two discrete objects, and the other experiment, no, it only creates one. And we won't even care about width of the slits and stuff like that. That doesn't not of consequence. All right, so again, Holliday's implying that there's some humility in the conversation, that when physicists talk about it, they demonstrate some respect for the fact that they don't have hard evidence, that they don't have nail in the coffin evidence, that they can't be sure what's really going on, and that it's perfectly viable to argue for a particle theory. None of that takes place. They argue for waves and worse. Waves, and it's always fields. It's always the electro and magnetic fields that are somehow manipulating the photons. They're these fields that have no description. There's no nothing but circumstantial evidence for their existence. No real hard evidence. Again, really weak evidence, and the evidence is really just a circumstantial, in the sense that you can contrive lots of magical things to cause events and get away with it, apparently, without having any evidence for them, merely because you say, yes, the leprechauns did it, or the pixies did it, or the gremlins did it. You can blame lots of coincidences on magical forces, or you can recognize that there is such a thing as a coincidence. So there's no logic in this, and there's no fairness to the facts. And he's calling that reasonable humility demonstrated. A good scientific temperament has been displayed on this subject, and there has been no scientific temperament. It's completely fanatic, fundamentalist. It's religious. They've accepted a dogma, something, an unproven fact, and they've established it as that, a fact, when it's unproven as a statement, as a declaration of how things work, and they're just saying, no, it's good enough for them. And this is in the context of, again, scientists accepting things like Huygens, just magical properties, infinite numbers of waves being created, mechanisms that can't possibly even match their own physics. They contradict their own other physics they've established as physical laws, and they just throw them out the window and grab hold of this goofy godlike answer. Alright, so they always say things like it can't be otherwise explained, that it's beyond any kind of other explanation. It can't be anything but waves. Waves are the only possible, and there's never any conversation about other possible mechanical mechanisms that would cause the effect. They just don't bring up a subject like deflecting photons, having them interact with electrons and change their path, even though that's the most common things electrons do, is move forces in new directions. It's just not even talked about as a possible explanation. It's not explored as a subject at all. You'll find nothing on it ever by any college professor. Will never even speculate about any element of a particle theory. So again, the single photon making two photons, you just say, shouldn't you just stop right there and say that's sort of an extraordinary claim? It should have extraordinary evidence. It should have at least ordinary evidence. It should have some kind of evidence, and there really just isn't any evidence. Alright, so this is the important part, because everybody just thinks math is everything. So understand the math is just a simple equation that establishes a relationship between variables. So the variables are the distance, the light is from the target. Well, they don't pay any attention to that. The distance from the slits to the target, they have to pay attention to that, because that's going to decide the depth of the spread. And the rest of it's just how wide is the slit in the single slit, and the wavelength of the light, and that's it. And it's just a relationship between those variables will tell you what you're going to get. And it's not that complicated, and it can be understood as just being essentially an angle of deflection, and they actually have the angle in the math. They call it the sine of theta, and they're just really calculating, the divergence of parallel lines in a sense, um, and to decide how big an angle deflection the light will have. And so the first thing that's relevant is the distance to the target. The second thing that's relevant is the width of the slit, and the third thing is the frequency of the light. And those three things will decide how much. Well, I probably wrote it better than I just said it. The math just formalizes the relationship between frequency, the width of the slit, and the resulting angle of deflection or divergence. Now, when they do the double slit math, they don't use the width of the slit, they use the width of the impediment, but then they change how they number the product. So the effect is labeled differently, because there's quite a substantial difference between doing the width of the slit versus doing, the width of the impediment versus the width of the slit. But you can sort of understand that the proportions might be related. So, it wouldn't make any difference as long as you compensate for the change. That you change one variable, that you have to change other outcome labels, that you change the variable. So you can speculate on a theory that the angle is just something you're going to measure it against some sort of constant. So one of the constants, so you could establish that the wavelength might be a constant, that might be something you can establish for each wavelength will have a proportionally different effect. So if you double the wavelength, you double the effect. And those proportions turn out to be true. And so all you're really doing is saying, what's the angle of deflection? And it can be broken down into just something that simple, in the sense that if you just establish that for red light, the amount, the core, the divisible number that you can put in, let's say the minimum amount of deflection would be, say, 3 degrees. So you could argue that the amount of change from the center to the first maxima, or the second maxima, however it's described, would be just 3 degrees. So you can establish that's the minimum amount something gets changed. And then it's proportionally 6 degrees for the next one, 9, 12. So those proportions exist. So that's almost like a constant in terms of there's a regularity to the pattern. It's not an irregular pattern, it's a very regular pattern. And so it turns out you can just logically formalize that if you just establish a relationship that is between the angle, and instead say it's a derivative, it's probably not the right word, you just establish that, let's say for every impact with an electron, it would move 3 degrees in a direction if it's red light, and if it's blue light it would be 2 degrees. Well, let's say 7 for red, just to make them bigger numbers, and 3 degrees for, or 4 degrees for blue light. So red light's 7, blue light's only 4 degrees. And once you've established that relationship, which is really easy to mathematically establish as just being a proportion, you just divide the wavelength into whatever number you have and you'll cut it by that proportion. Especially when using the sine of the angle theta, which is essentially just taking it, turning the angle into a percentage of 360 degrees. But anyway, you can come up with the same. It'll give you the same results, but you just say if it hits 1 electron, it moves 3 degrees. Hits 2 electrons, 6 degrees. 3 electrons, 9 degrees. And even if it goes left or right, so it can go either way, the 3 this way will always just undo the 3 that way, so it'll never break that consistency. So you'll always end up with a pattern that has a consistent difference, and it will always be less probable that something comes out with a 12-degree divergence than a 3-degree. There'll be a lot more that are at 3 degrees than there are at 12 degrees, because it's harder to hit more electrons, enough electrons going the same way. Now that it explains the pattern, it explains why it goes in both directions, because each side is creating that same probability, and it explains that why there's a relationship between how narrow you make the slit and how much pressure the electrons would be under, and how that will change that degree number. So there's two factors that will affect what the standard degree is, or what the sine theta product is. And the two things are just the frequency of the light and the width of the slit. So those two factors are essentially divided into the constancy of the regularity, the distance you are from the slit, which still is essentially establishes a kind of another variable, but again it's another regular variable, and it'll always be a percentage of that distance. Will tell you how many degrees. But that really doesn't, the distance doesn't have anything to do with the degrees, because the degrees happens at the slit. So it's just the wavelength and the width of the slit. Those two numbers decide how many degrees, what the unit, that's the word I was looking for, what the unit of potential change is. So whether blue light diverges by just 2 degrees or 3 degrees will be decided by how tight the slit is. And so the tighter the slit, the higher the degree number goes. And the wider the slit, the lower the degree number goes, which is completely consistent with the pattern. So again, there's nothing magical in the math. The math doesn't have any presumption of particle or wave. It's just establishing that there's a change in how much the light deflects, how much its path is changed by going through the slit, and that pattern is predictable. But there's no obligation to turn it into wave interference at all. Right, kind of a wordy way to say it, but it is what it is. Alright, so the important thing to realize is their math doesn't actually accurately predict the pattern, because the pattern doesn't do what it's supposed to do by their wave mechanics, which is have a smooth transition from bright to dark, where the particle model explains why there's no transition, because it is kind of rigid. And the only thing that changes the width of the little individual bars is really how much difference there is in the distances, between the surfaces. So you can sort of understand there's 4 ways in just a single slit. There's 4 ways a photon going in can go. It can go that way. It can go that way from this side. It can go that way, and it can go that way from this side. So there's 4 directions, and those 4 directions are what's just creating the width of the slit, because they're from a different position. So it's essentially, it essentially creates 2 objects, in the sense that there's 2 objects. There's not 2 photons, there's 2 objects in this single slit experiment, and there's essentially 4 objects in the double slit experiment, which means there's 8 possible directions the photon can go. But that decides how wide the pattern is. So as you narrow the slit, you create more probability of hitting more electrons, which just makes everything go wider in terms of its potential of where it's going or heading, or will land. But you've also changed you've increased the probability of those deflections, and in a sense magnified, just zoomed in to the pattern. And then you can zoom out of the pattern by making the slit wider, because you change how close those lines end up being. Okay, so again, their math doesn't have in it doesn't have any explanation for why the pattern isn't consistent with what it should be, which is a smooth transition from on to off and on to off and on to off. It shouldn't be essentially images of edges. So anyway, so a perfectly viable explanation is not discussed, not explored, and is obnoxiously and superficially ridiculed as not even a conversation worth having. Because Einstein didn't think of it and destroy the two-slit experiment in its inception as an issue. Well, when it became an issue in the 1900s. See, this is part of the history, right? So the 1650, Newton discovers Newton's rings. 150 years later, Young discovers, oh yeah, there's light diffraction, which Newton had already discovered. And then it wasn't until 1915, or whatever, 1910 or something, that Einstein figures out that photons are, little packets of energy. And the conversation, and it wasn't until 1930 that this whole quantum mechanics stuff started being generated as a theory. And so it's a very strange context that there's very little in between those years, in terms of conversation or anything dramatic happening in terms of a theory regarding particle or wave, or explanation. I guess the idea of the electro and the magnetic fields, which is a modern invention, is I think that's like a 1900s kind of thing, is where they just found some other mechanism to explain why photons move, that they're moving through a medium. So that's the part we'll hopefully get to here. Probably have to move this up a little. I don't have to, but I did. Yeah. So far, yeah, it's working okay. All right, so something that's another part of this that always bothered me is that there's so little conversation about how photons are produced, and the fact that it's not like a radio wave or something. See, a radio wave fools people because they think it's the same thing, but it's really, photons that you produce you're actually producing the half of the light at a time, so to speak. So you're creating the wavelength between, you're creating the length of the thing called a photon. Now, my argument would be the photon is really just two things separated by a distance. And when it comes to things like light, we don't have any mechanism to regulate that precisely. We can certainly create blue light and we can create red light. So we can create some variation in that frequency, but we can't really control. Look, we can control it because we can create microwaves and we create all things, but it's such a tiny frequency that the machinery to create it, to create a photon, isn't something that we can so tightly regulate that we can be sure that each group of photons is exactly lined up, like each ray of light. So the rays of light move at a frequency in a direction, and the odds, or the ability, it's very hard to make various rays of light that are all lined up as they move, because each ray will have a little bit different phase, and so there won't be a consistent phase in most light. Light will be, it's hard to have all the photons in a beam of light to be all on the same phase, that is, all lined up where they all come out at once. Now with a radio it's really simple to do it because the antenna just vibrates much slower, and you can regulate when the photon, when the piece of the wave, the first part versus the end part, is produced. But with photons you can't really do that because they're emitted by jiggling electrons, and it's hard to jiggle a bunch of electrons all at once and then have them all silent, and then jiggle them all at once and then have them all silent. We don't have any technology that gives us complete control over that. So this is a real problem for much of this theory, because you really can't have this wave interference thing. It doesn't work too well if these things aren't perfectly, if they're lined up wrong, it doesn't work. You have to have them lined up with each other, and that's not easy to do with photons. Okay, so again, and then EMF, this idea of, you could say the electromagnetic force or electromotive force, but what I'm really saying is the electromagnetic spectrum is nothing like sound. So in the sense that, depending on your theory, depending on how you're viewing it. So if you view it in a sense, you can say, look, I understand what sound is. Sound is a medium that vibrates. The pieces don't move, it's just that they're all locked together. So there's a bunch of atoms, and they're moving around like this, mostly. Now if they're very hot, they'll move a little more energetically. But the idea is they're under pressure. No matter where they are, they know they don't like each other. They're bouncing off. They're not combining. Well, they will combine if they have the right temperature and the right chemistry. I'm just saying, generally speaking, things like the atmosphere, the molecules are not, the type of molecules they are, don't easily combine into big elements. So oxygen atoms don't just combine into a big oxygen. They need a catalyst to do that. They need a H2O thing. Two hydrogens can combine with an oxygen, but it's not two hydrogens don't stick together and become, double hydrogen or then triple hydrogen. They don't precipitate out as other elements do. Other elements stick to each other. Gold or some other thing. They don't love each other, but they like each other. The atoms will stick to each other. They won't bounce off of each other. So depending on what your medium is made out of, that's usually a medium that's going to transmit anything. Has to be atoms that don't stick. They don't stick together. So they do a lot of bouncing, and they're under tension or pressure. And so when something moves one of them, the other one feels it, because there's a magnetic force between them, I would argue. So it's just like a bunch of magnets. I could take a field of magnets, all north side up, little magnets, little flat magnets, and I could, if I put them between two pieces of glass, let's say, I could move just one of the magnets and all the other magnets will move. And that's what the wave is in medium. That's what sound is. Sound is a vibration transmitted between atoms. They're jiggling, and then they get hit with a new jiggle, and that jiggle is passed on, and that signal is passed on. But it's just movement. It's not like the atom goes the full length of the change. It's just transmitting pressure. So it moves a little closer. This magnet says, I don't like that. It moves. The next magnet moves. The next magnet moves. The next magnet moves. So that's how pressure is transferred in mediums. Now, if you believe there's a field of magic, the electromagnetic field, electrical field and a magnetic field out there, and that they're under pressure, and that somehow photons are just signals through that pressure, well, you can do that, but to me it's an insanely unnecessary step to create a whole infrastructure of pressurized non-reality, some sort of non-real things that somehow is pressurized, and it could be made up of particles like the other mediums. Again, you can't, if you're going to argue that it's like sound, that the waves are traveling like they would travel through water or travel through atmosphere, then you have to account for the fact that, well, we know why those things travel through those mediums. It's because those mediums are under pressure, that there's tension between the atoms and they're transmitting that tension. They either directly bang into each other, push each other, or they have a tension between them, and that tension is transferred. So I guess the way I wrote it is, movement of a wave in a medium is the movement of many locked atoms, particles that are in phase. So the phase of sound comes about, the reason why you can talk about waves being in phase in sound is because the atoms are all the same, essentially, and their tension is even. They distribute the tension as evenly as possible just by the laws of the rules of their communication with each other. You can't help but be passed on. And so they tend to be in positions, and those positions will move a proportionally equal amount, and so the wave will progress this way the same as it progresses the other way, because it's moving through the same amount of pressure. And so everything stays in phase. Now, there's no mechanism that requires that for these little photons to be doing that. And again, if you're going to create those fields, you'd have to say that, well, if I'm going to be consistent with the model of sound on the model of water, then you have to say that your electric field is really made of a bunch of little particles that are under tension. So you end up with a particle theory anyway, because the thing you think isn't particles, water and air, it is, in fact, and that is how the signal's transmitted. The individual bits don't move, they just transmit pressure. They move a little, they don't move a lot, and that little bit of movement is transmitting pressure. So the water at one end of the wave doesn't go the whole distance of the wave. It just transmits the increase in pressure. The amount of atoms in a space is increased by increasing the pressure, by just moving a bunch of them one little bit, and the next ones will move one little bit, and the next ones will move one little bit. Alright. That's pretty, I mean, that's kind of like 8th grade physics, but anyway. Alright, so then they have this thing that Professor Lewin used to always say is light plus light equals dark. And that kind of thing doesn't happen, in fact. And so the whole comparison to waves doesn't hold, it isn't very consistent, it isn't very durable as a point of view, because it's not how it can be understood, is that the light goes somewhere else. So again, we're back to it's really about a particle. It's not about some wave that cancels. You know, that two effects can come into each other and they're exactly the opposite, and you get a neutral, and you just kill all the energy because the energy consumes each other. Well, that doesn't happen with photons. The photons actually go somewhere, and that's demonstrated with the interferometer, where whatever you have at one end, if you you know, at the receiving end, if you monitor the other path the light takes, you'll see you'll have exactly the opposite at the other side. So wherever it's dark, it's not dark because two light plus light turned into dark. It's because the dark went somewhere, I mean the light went somewhere else. And the same thing's happening in the two-slit experiment or the single-slit experiment. The light's going to where the bars are, and it's not going where the bars aren't. But there was no photon destroyed in the process. Okay, so another part of the two-slit is they'll always talk about their effort to, well, when we monitor the photon to see which slit it went through, and they don't clearly say, we have absolutely no way to do that. That there's absolutely no way to detect a photon. Just can't happen. And so the only experiment they have some hope of doing it in is the electron experiment, or the buckyball one, but we haven't heard about them trying in the buckyball to tell which slit it went through, because that would obviously be easier to detect. But I think you can logically infer that the reason why they don't do some of these experiments is because, yeah, the results aren't likely to be fun, because they're going to basically say there's something wrong with this theory. And a serious effort to detect electrons really should be possible to tell which slit they go through. It's just that electrons, you have to make them go through a vacuum. They can't travel through the air and go through the slits. So it's a little harder to make your apparatus to detect an electron going through a tiny slit, because it's in a vacuum and in a hugely energetic field you've had to create to get the electron to move. It's essentially a spark of a kind, and so it's very aggressive. So any detecting instrument is likely going to be destroyed by the environment it's attempting to detect an electron in. But anyway, the idea that a photon could be detected is just, there's no theory that justifies any conversation about detecting photons. There's just none. They don't. There's no evidence that a photon ever says hello to something in some way as it goes by. It either visits or it doesn't visit, and it either hits an electron or it does nothing at all that can be in any way known to have happened. It doesn't do a happening unless it hits some piece of matter. Yeah, so I was going to do interferometers also because the two subjects are related, but I figure, I'll save that for another conversation because there's so many elements involved in what's going on there. But again, it goes to this conversation about phase and the fact that this idea of matching a photon with some sort of pair, and you're going to send them off on a different path, and then somehow you're going to measure them again, in some kind of product place where they were, where they had the same starting line, they have the same finish line, and you're going to measure the difference in what they traveled. And it's, in my opinion, probably wrongly premised to think that we have the ability to do that, to have photons close enough to, in that condition of sameness, in terms of position, the same starting position. We have no evidence we can create photons that have the same starting position, and so little evidence that we could measure differences in their what happens to them as they travel. Yeah, so I don't know if I need to draw pictures. I'm ready to, but I don't, some of this is, so just going over it. So there's a few issues that are just, okay, the idea of Huygens, the idea of creating this unproven mechanism that's sort of vital to their explanation of this reality. In the sense they need some mechanism to force a photon that goes through a single slit to somehow create two things that interfere with each other. Now, the catch is they always use water waves in the two-slit experiment as a comparison because the outcome is somewhat similar. The outcome in water waves and the outcome in light in two slits is similar. But there's no similarity in the single slit, and there's no similarity in the multi-slit water experiment. The two don't behave the same as light. And so this is kind of glaring evidence that there's probably something wrong with this metaphor, this wave metaphor, because it doesn't hold true, but they keep implying that it does, like somehow they have evidence that that's what it does, because it does it in one instance, it does it in all instances, and it doesn't. So that's just more of just telling the story incorrectly. It's just it's just not honest. It's not an honest rendering of what the evidence is, and what conclusions were based on evidence, and what conclusions or mechanisms were just based on creating a fake mechanism to answer the question. Just basically somebody asks you, who turned over that pot, and because you don't have an answer, you say the gremlins did it. And this wave theory and Huygens is just gremlins. It's just a made-up force explanation, a mechanism, a made-up mechanism that doesn't have any, that just has all the appearances of being just that, just something you can just make it do anything you want. So we have this magical ability for a photon flying through space to detect that it's going to go through some confinement, and now in some way, shoot out radar or little baby photons, millions of them, so many that each one creates its own little wave, is the theory. An infinite number of little things break off of this thing, and it creates a whole bunch of little things, and then all those little things decide where the appropriate place to go is, and then the big thing grabs all the little things back again and hits that place. I mean, it's like a Transformer movie or something. It just doesn't have any connection to reality. What's really possible. Um, you know, Practically or sensibly, that there's any evidence that we'll ever have the ability to do anything like that. I mean, it's just magic talk, clearly. And their whole theory is dependent on it. Without it, they're just stuck with, I don't know. It just does. That's what they're stuck with. Yeah, so it's just, it's really poor evidence. Alright, so I could play some of the Hoffaday video, but I don't know if it's worth it. So it's just basically Hoffaday saying that there's some sort of scientific attitude in how the two-slit is presented. And then he showed a clip. He's often complained that you can't just watch online lectures. Now the actual lectures that people pay to go to, these are the actual lectures where students paid to get this information. And those lectures are somehow illegitimate. And yet he posts a lecture that was just for alumni's kids. They have like whatever, alumni kid day, to see if you want to go to MIT. And, 15 people in the audience. And he does a lecture on light. So it's just this one for it's for high school kids. So and he posts that as an example of real science when it's clearly just the opposite. It's dumbed down and made sillier. And so in this conversation, he's talking about light. He goes through the traditional notions of saying this proved and that established and this is proof and proof, and then in the end he does some wishy-washy conversation. In the beginning he does too. He says, well, I thought I knew what light was and blah blah blah, but then I learned quantum mechanics and it's totally, I don't know what it is. But in the middle he's saying it's proven, it's a wave, it's a wave, it's a wave, it's a wave, and then at the end he says some mush about like, well, there's this duality, and I could do a lecture on light as a particle. Well, I've never seen a college lecturer ever do that. So he says he could do it, but I've never seen one of them ever try to do it. Because it's just not their religion. And so we're often to call that an example of humility. I call that an example of just how full of shit it all is. That they're so used to saying, you can't understand, nobody can understand. They're so used to saying this. You can't know God. You can't know our special God. He's a God, and we're just human. We can't know the photon. No. It's in a special universe, and it's far, far away. No. So we'll have to stay a mystery. Woo. The special electric field and the special magnet field. No. I'm sorry. To call that humility, I call that lack of credibility. I call that junk science. I call that religio science. It's shit. It's garbage. It's not a rational conversation about reality. This premise that you can't know reality. That's a false start. And it stinks to high heaven. That's the desperate act of people who don't know what they're talking about, is to say, you can't understand. We can't understand. We can. It's just, they've given up on trying to explain anything in a mechanical, sensible way, and have just decided, no, we're going with this wacky theory, because it's more fun. And it's what everybody's just brainwashed into. Just like most of the people on Earth are still religious, even though it's a nonsense. It's just totally been debunked in every way by an alternative theory that's just totally answers all the questions. And the only reason why people still cling to it is because they're badgered into it as kids. And the same thing is happening here. This is just a badgered conversation. It is the droning of the wave concept is pushed, and there's no balanced conversation about what's could be a simple mechanical explanation. Alright, so yeah, that's enough. So there's no point in me playing it. I mean, I could play it, but it's just, it's worse than his usual. It's worse than, I mean, like I said, I've already played Professor Lewin doing the same thing Feynman did and all these other people did, where they just draw the blob of light coming out of the single slit experiment. The same bullshit explanations, the same nonsense that then Young in 18105 proved light was a wave with his magical experiment, and there's nothing magical about it. Didn't demonstrate any new phenomenon at all. It's just Newton's rings with two openings. Just totally unremarkable as an experiment. Should have been of no notice to anybody who understood, who knew who Newton was. Anybody had a little knowledge about Newton and all his glass experiments and aperture experiments clearly would not find Young's experiment at all remarkable, at all surprising. So the whole thing is just built on bullshit. Yeah, there just hasn't been a fair conversation, hasn't been a fair fight, hasn't been a fair trial of the evidence. It's all just been one-sided and decidedly aggressive, obnoxious to any challenges, and duplicitous in the standards of evidence. Complete double standards in terms of what the theory has to explain. If you're going to advocate for a particle theory, you have to explain every detail. If you have a field theory, electromagnetic woo 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 woo, tells things what to do. Yeah, open-ended. Huygens, just infinite number, sure, it's okay. We'll break all kinds of basic rules to accept your explanation. Your explanation is perfectly viable. The fact that it has huge flaws in it doesn't matter. But the particle theory, like for gravity, for example, that'll be some other video, destroyed because of one little problem. One little problem of too much drag in the system. So one little problem wiped the whole thing out. But Huygens speculating about infinite number of microwaves, mini waves, no, that's okay. That's not a problem. Physics loves that. Infinite number of something in a confined space. That somehow makes sense to new physics. So anyway, garbage. So until next time and such. Yeah, maybe I'll do a second version and just do drawing or something. I don't know. Yeah, it's tired. So this is all you get for now. I mean, it's a lot. It's enough to make the argument. Particle theory can't explain this. I guess that's one part I can draw right now. Should be the drawing program. Yeah. This percentage, this argument about the movement of the in the experiments. We might as well just use two slits for the sake of, I don't know, doesn't matter. So the argument is that there's electrons on the surfaces, interior surfaces. Okay, I should draw the electrons in red, idiot. Yeah. So these are electrons. And you can probably visualize that they're in some sort of condition, depending on the charge between the surfaces. So the truth would be is that these would all have a kind of a neutral charge because they're all connected to each other, usually. It's usually two cutouts. And it's really hard to put a charge on objects that are really close together. So this is a tiny amount of distance. So it would be really hard to put any high voltage on this without it being negated as a factor. But it is true that in high voltage experiments, when you have like the Jacob's ladder or whatever it's called, and the electricity goes up the ladder, that if you actually shine ultraviolet light into that space, you will increase the speed with which this rises. So you'll essentially increase the activity of those electrons, their conductivity. Anyway, but that's it's not another subject actually, it's a similar subject. So anyway, the idea is these photons would be in some kind of arrangement, on, just lots of them, and they're going to be in positions, and they're going to be repulsive to each other on both these surfaces. There's going to be a similar number on both surfaces. Not the same number, but a similar number. And they're going to not like each other. And so as you bring the slits together, they're going to be tighter and tighter packed, because of that pressure, that repulsion. So the idea is, though, is kind of simple. So if there's a group of, I'm just going to make it bigger just for the sake of, visualizing it. So there's electrons arranged, and usually arranged in probably some pretty rigid geometry. And the idea is that the photon would come in, and depending on the arrangement of that pressure with the electron will either be more likely to go a little bit in one direction or the other direction. So the electron's going to move a little bit, and then this pressure is going to be released, because when this electron moves, it's going to mean that the pressure that was between these two electrons, let's say, a little bit of that pressure is going to leak out. So now the photon has this new direction. So it got absorbed as pressure this way and reflected, and so now there's pressure going this way. But the energy was transmitted to another electron, and that extra pressure ended up releasing another photon. And then so that would be your 3 degrees or 7 degrees, depending on the light. And then it would hit another electron, and it could go 3 degrees this way or 3 degrees this way. So it could be at 6 degrees, or it could be back to straight line 0 degrees. So at each interaction, it's going to change how many degrees it is. So it would be, like I said, the pattern would end up being, here's your middle, where the light just went right straight through the middle, so that's going to be your brightest. And the rest of the pattern, remember, these are all diverging out of a tiny area. So there's this space, this whole distance, of width, is just a tiny percentage of just one of the bars, the center bar. It's just one line in the center bar. And so the rest of the pattern has to be all stuff that diverged at these specific degrees. So this would be 3, and then 6 degrees, and then 9 degrees. And because it's coming off 2 different, in this case 4 different surfaces, each surface would be a little bit different alignment. So each surface would hit a certain little different location, and that would account for the differences. And then you have to consider the other thing that's going to affect the width of these bars, how wide they are, distance wise, is the fact that these electrons are going to have a certain depth of their own. So there's the slit material, and then there's a thickness to the electron field, and then you have the other side, the electron field, and then the material. And so there's 2 things that will affect how much variance, how much width there is to your bar pattern. Is this distance, which will be affecting the fact that there's 2 different sources, and then the fact that inside of those sources there's a thickness of electrons, which they'll all be at different positions. And those different positions will end up with 3 degrees, will mean something different here versus here, or here versus here. 3 degrees from those different locations will be reflected in the width of that, how much space is between the dark bands and the light bands. So alright, so I just, as I was just drawing these bands, the key thing to recognize, see, this is what's called interference, when these things are all equal and these spaces are equal. The empty spaces are the same size as the bars. And let's remember, in the interferometer, the dark lines are smaller than the lines of the light, the thickness of the light. They're not proportionally the same. But anyway, often, I mean, there can be times when they appear similar, but I just mean there's often times when these widths are not consistent at all, in the sense that this one will be much, I didn't draw it very well, be much thicker, and then the next band is thinner, and then thinner and thinner, which is the opposite of what happens in the actual experiment with the slits. But anyway, I just didn't want to mix the two subjects. So anyway, that's enough. But yes, drawings do help. Let's think. Anyway, until the next time.